Hello, and welcome to the showcase video for the Coca-Cola Reverse Osmosis Optimization Senior Design Project. My name is Sydney Weinstein, I'm the team lead. I'm here with my fellow groupmates Karina, Paul, Dakota, Madeline, and David. Although we were not able to work hands-on in person together this semester, our group continued to maintain different avenues of communication, including Zoom, group chats, and even mailing different parts of the project to each other. And with strong teamwork and work ethic, we were able to successfully complete our project following social distancing guidelines. I will now turn it over to the rest of the team to further explain our project.
Our senior design project is centered around improving the water filtration system at Coca-Cola's Main Street production plant in Auburndale, Florida. Coca-Cola's water filtration system is not keeping up with the growing facility and industry standards, especially the recovery reverse osmosis system, which became the motivation for the topic of this project due to its significant role in water filtration. The recovery RO system oversees cleaning and reserving concentrate output from the nanofiltration and reverse osmosis systems. The proposed design would eliminate downtime for maintenance, improve the recovery efficiency from 75% to over 90%, maximize the volume of permeate produced, and generate over 13 million gallons of permeate every year, all while further promoting water conservation.
To justify our system design, the team used a reverse osmosis simulation software called WinFlows. It allows us to implement our 6-stage RO system design to test and simulate the potential overall increase in efficiency and permeate recovery by adding the addition of an array. This simulation requires the user to input specific data such as feed water, conductivity, pH, and ionic parameters, as well as the amount of pressure vessels in each array, the configuration of the system, and importantly, the membrane type. All parameters were defined to match what was recorded from the recovery RO system at Coca-Cola currently. From the left is the feed water running at 135 gallons per minute. In the middle are the twin arrays, both specifically defined at 75%. The permeate outputs are shown in blue. Array 1 has an output of 101.25 gallons per minute, which is similar to the plant's original recovery output. However, with the addition of Array 1's concentrate being fed into Array 2 as shown, Array 2 has also an output of permeate of 25.41 gallons per minute. So, the overall permeate flow rate is 126.56 gallons per minute, and the total system recovery is 93.7%, a near 20% increase from the current recovery RO at Coca-Cola.
Red is the water drained by the current system, and the blue is ours. The area in between is how much water we end up saving with the new system, which is over 13 million gallons. And to put it into perspective, if each dot equaled the water in 2,000 bottles, we'd end up saving 120 million a year. A challenge was organizing a group of 6 to make it out to Auburndale as frequently as possible, but the more we spoke with our stakeholders, the more we took into consideration that most of the cost comes from the sewage of the drained water, and we eliminated that as much as possible, which would end up saving them $150,000 a year just from the sewage alone.
The team was able to create a highly accurate 3D CAD model based on the currently employed recovery RO system found in the Auburndale production plant. This large assembly made with real piping is completely devoid of any part interferences, is made with correct material properties too, as designed by Suez, the manufacturer. With this model, the team was then able to create a virtual representation of our proposed design, where an identical array equal in capabilities to the original is connected by valve manifold. This valve manifold, made of gray solenoid valves equipped with actuators, receives the feed water of the system and can send it into Array 1 or into Array 2 based on the mode of operation. This valve manifold also receives the reject water of the first array and can send it either directly to drain or into Array 2 for further filtration based on 2-stage RO design. The biggest lesson the team learned from senior design would be the importance of correctly identifying the critical requirements regarding a proposed solution in order to offer the customer the best solution.
In front of me is our physical prototype. This is a small-scale prototype that represents the overall main system that we designed. The main parts are visible. First 3 pressure vessels for Array 1, second for Array 2, boost pump, glass carboys for concentrate and permeate water production, the crux of our design, which is the valve manifold, and electronic control components, which are delivered commands from this computer. And after this, I'll show a physical demonstration. Here is the system in operation. Water comes from the garden hose into the feed water. It passes through the open valve number 1 and is fed into Array 1. Permeate is produced. The reject concentrate water from Array 1 is fed into the boost pump, which increases the pressure, feeds it back into the valve manifold. Valve 4 is closed. Water is redirected through valve 3 and into the intake of Array 2, again, permeate is produced. Finally, the final concentrate stream goes into a flow restrictor and into this holding vessel.
We really enjoyed working on this project, and therefore it's easy for us to stay focused during the challenges of COVID. And even though social distancing was hard, we were able to meet and work from anywhere, which worked really well with our team's busy schedules. There are many things we learned this semester that we will use in our future as engineers. Thank you for your time and consideration with our project.